in section 1.1, it was all about lines. So, the point slope was a big thing. Finding equations of a line, finding equations of slope. Finding equations of lines given like two points, given 1 point and saying like it's parallel to this line or it's perpendicular to this line. Do you guys remember doing that? So stuff to expect. X and Y intercept. What's an X intercept? Yeah, when Y is 0, where it crosses the x-axis. Okay, that's also a 0 is what it's called. Horizontal and vertical lines. Horizontal being like y equals 2, meaning the y values are always equal to 2. Vertical line being x equals 4. All of the x values are equal to 4. So that was all the stuff in 1.1. 1.2 was a bunch of function stuff. So we did domain, we did range, we did interval notation with a bunch of functions. We did even and odd, both algebraically and geometrically, meaning like what happens to the graph, that being geometrically. We did piecewise functions, like how to put them in your calculator, how to get information from a piecewise, if I ask you questions about it. We did composition. Both f of g of x can be written both of these ways. Fog x or f of g of x, meaning take the g of x function and stick it into the f function to create a new function. And we also did this. What does that mean? F of g of 5. Yes? Which function first?
G of x.
Yeah, you put a 5 into the g function, you get a value, then what do you do?
And you take that value and put it in the x.
Yeah. Does that make sense, you guys? So expect stuff like that. Exponential functions, we did graphing. Exponentials, we did domain, we did range. A lot of the stuff, some calculators, some not. Growth versus decay, if it's a 2dx or something bigger than 1 is a growth. Something less than 1, bigger than 0 is a decay. Like these are all different, like what they look like, kind of like the transformations of an exponential function. And then we did all that stuff with compounding interest. So take a look at that as well. In parametric equations, we're able to, even though it's in terms of t's, we're able to define the function in terms of x's and y's. So, substitute one into the other. Graph parametrics and like get information, like starting point and stuff like that. Like at time 0, where's this thing at? Where does it go? What does it look like? Is it a circle? If you actually were graphing and you had your calculator, be able to do that. Does that make sense, you guys? That's what we do with parametrics. In log, solve for variables, meaning if your variable's up there, like how do you get that variable out and get it by itself? One-to-one functions, finding inverses of functions, both algebraically or graphically. Algebraically meaning switch the x's and the y's, and then solve for the y's. Graphically meaning just flip all the x and the y points. Just flip the points and then you can just regraph it. Prove that two functions are inverses, and how you do that is you compose them. Let's start on. You compose the two functions. If it's equal to x, then those are two inverses of each other. And then some stuff with log graphs, just be able to put it in your calculator and take a look at the picture. Maybe domain, range, things like that. Okay? In 1.6, we got graphs of sine, graphs of cosine, doing some transformations on it, like shifting it left and right, up and down. What's the period? What's the amplitude? Given a graph or given an equation, answering those questions. And doing stuff with inverse trig, like, the inverse sine is equal to this, well, what's the angle? Different things like that. Okay? Also, summer packets due tomorrow. Some stuff in the summer packet may show up on the test. Not a lot of that. So as far as trig, we're not going to go too in-depth into it where you need to know a lot without the calculator yet. But that's what we're working on in boot camp. But later on we are going to have quizzes and stuff with, I'm going to ask you for what's the sine of 225 degrees by hand. And we'll get to that. But not yet as far as what you're going to be tested on. Most of this stuff is just going to be all stuff on the calculator as far as anything I'm going to ask you to trade. Does that make sense, guys? But later on that will change. And then, so there's stuff from the summer packet. This was one section. I think everything else was everything in the summer packet. This is stuff that wasn't in chapter 1. So how to simplify things like this. If you need practice on it, talk about it in the group, talk to me. But things I'm going to expect you to know how to do possibly for tomorrow. This is anything that's fair game. Okay? Any questions on any of this? Sure. So there's two ways to do it. You guys have it in your the two different ways. Well, I do it different than Ms. Sykes does. So I don't want to confuse some people. I'll show you my way, and I'll show you Sykes' way first. Hers is actually easier in this. So I was like, the Sykes' way. But I like my way better. Do you know why? Because it's my way. And it just makes sense to me. It's like it's how I've always done it, so I've always stuck onto it. Does that make sense? In either case, you have to multiply something by 1. There's no equation here, so you can't multiply both sides of the equation by anything. So the only thing you can do is multiply things by 1, because multiplying by 1 doesn't change it. Right, Michelle? So what Sykes will do is she'll multiply this thing by x over x, meaning multiply this whole part by x and multiply this whole thing by x. Okay? When you do that, you get x times 5 is 5x plus x times 1 over x is 1, divided by, this is 2x plus x squared if it's x times this whole thing. And what you just do is the goal when you just simplify is this is like a compound fraction, meaning there's fractions on top of fractions. I'm self-serving. This is how I roll. You know what I'm saying? That's where I grew up. Sassy. It comes out a lot. So that's one way to do it. And in this case, it's probably the easiest way to do it. How I do it is, I don't like, this confuses me, like how it's written there. So what I do, even though it's going to take more work in here, is I'll just take individual things and multiply it by 1. So if I wanted to combine, I don't go top and bottom until I clean everything up on the top and everything up on the bottom. I'll get a fraction on top, a fraction on bottom, and then I'll move forward. Okay? So what I would do is if I wanted to add 5 plus 1/3, how do you do that? I mean, yeah, so how many thirds, like one way to do it is just multiply this by 3 over 3. Multiply 5 by 1. And you get 15 thirds plus 1/3. I didn't change this number because I multiplied by 1. 15 thirds is 5. But now you can add those two fractions together. Does that make sense, David? Okay. 16 thirds. So what I always do is I follow the same rules. It's the same rules, If I want to add these two things together, I need a common denominator. What's my common denominator? X. X. So I need to multiply this thing by x over x. 5 over 1 times x over x. And I get 5x over x plus 1 over x divided by 2 plus x. Now I can combine these two things together. See it? So now I can combine these two things together. I have a common denominator, so I add my numerators. 5x plus 1 divided by what? X. Don't add those or do anything, because it's the same denominator. Same denominator. All divided by 2 plus x. So it looks like I made the problem worse, doesn't it? Right. So what I do is, I don't like the way this looks. You're given squinty sad eyes, it looks like. So what I write is, okay, 5x plus 1 divided by x divided by 2 plus x is the same as 5x plus 1 over x. I'm going to rewrite it like this. Would you guys agree that this says the same thing as that? Yes. So then what I do is I'll rewrite this as 5x plus 1 over x times, dividing is the same as multiplying by the reciprocal. So then I'm going to multiply this by 1 over 2 plus x.